morning, everyone. Okay, please put your camera on. Okay. Okay, anybody has any questions before we get going about the homework or anything? Speak up or put it on chat. Any questions? It's your chance.
Before we take the quiz today, could you go over some of the notation problems? Because I'm a little confused on what to do for those type of problems.
If I understand you, you mean the interval?
Yeah.
Yeah, okay, let's do that now, all right? Quickly, okay? And then we get going. Okay, I'm gonna draw a function. Are you with me?
Yes.
Okay, just draw, nothing special, because that's how you're gonna use them in, today and later on. So suppose I draw a function like this. So this is -1, this is 0, this is 1, this is 2, this is 3. And I draw it like that, going up, and then I'm gonna make it going down. Okay, very simple scenario, and going up. Okay, 1, 2, and 3. All right, simple scenario. Please turn on your camera. I hate to bug you with that, but I would like to see your faces. It helps me. All right, so the question is, suppose I ask you on which interval the function is decreasing, let us say. Okay. All right, so tell me in word, when is the function increasing? In word, for between where and where the function decrease, and I'll write it in notation.
Well, if you're saying when it's decreasing, and are we putting like a whatever, I forgot what the word is, like the parentheses thing. I forgot the two numbers. I know it's like simple, but I don't know what to call it.
That's okay. But for on the graph, use words. Don't use symbols. In words, from where to where it decreases.
Well, it decreases between 1 and 3 at 2.
No.
2 and negative something.
No, decrease. What does it mean, decreases? It means on which interval as you let... Go ahead.
Right at the 0 line, it starts decreasing.
All the way to where?
On the way to 1.
Does it stop decreasing after that?
No, it keeps going on the way to something under 2.
Okay. And after that, does it increase or start? Does it keep decreasing or start increasing?
It goes back to increasing.
Very well. So I think the function decrease from here to here. Do we agree on that?
Mm-hmm. It starts decreasing at 0 until 2.
Right. So this at decreasing. So we're going to write it in words the way we understand it. And then we use the interval notation. Okay, so f is, let me take a better pencil. F is decreasing. So when is f? First in word, just what you want. For all the values of x, for all the values of x, or for all x that have the following properties. How can I describe everything from here to here? How can I describe it? So if I take an input between 0 and 2, what characterizes this input? This input is less than 2. Correct?
Yes, and it's greater than 0.
And it's greater than 0. That's what characterizes an input between 0 and 2. So I can say all possible input, if you want, such that this input, what characterizes it has to be between 0 and 2. Please stop me if you don't follow, because I have to know.
Let's talk about the market for a second.
All right, does this make sense? Can you guys hear me?
It says the host muted everyone.
Okay, yeah, because sometimes there is a noise in the background, but you guys mute yourself whenever you want to talk. Is that clear? So Aiden, I go back to you. Is this making any sense?
Yeah, I get it now.
Okay. Now in interval notation, so instead of writing all those values, sometimes we use the following notation. We say for all x's in the interval, in interval notation, you close at 0, close at 2.
That's what I was confused about, that part.
Okay, that's what. So 0, 2, it's basically an abbreviation for all this.
Yes, I understand now.
All
Thank
right.
you.
Any other questions? So if I say increasing, for example, so that's part whatever, increasing. When is the function increasing? Aiden, stay with me.
Yep.
From where to where?
Sorry, could you repeat what you said? I was looking at the email, sorry.
Uh-oh. Okay. Shall I take a point off his quiz? All right. That's okay. All right. When is it increasing?
It's increasing from somewhere past -1 up to 0.
All the way up to here?
Yes, and then it starts increasing again from 2 to whatever past 3.
Okay, so how are we gonna write this? 2 ways. I'll write it 2 ways so you're comfortable with both. So for all values of x, such that I'm gonna describe all those input up to 0. What characterize them? They are either less than 0 or
Greater than 3.
greater than 2.
Yeah.
So in interval notation, you can say all the values of x which are in the following interval. Everything below, you write minus infinity 0. Oh, sorry. Or if you want to say x bigger than 2, we write x in the interval from 2, everything above. So infinity is just really a symbol to tell you everything above 2. So it's really a symbol. It doesn't really have a value. It doesn't really it's not a number. It's just a symbol to tell you, okay, it means everything after 2.
So is putting like the parenthesis instead of like the edged part, is that just common practice?
No, that's important. No, this bracket, I will talk about that when I run into it. When you keep a bracket like this, parenthesis instead of bracket, it means 0 is not included. Okay, so don't worry about that. Now we're using bracket. Later on, I will introduce, if I put something like minus infinity 0, it means that 0 is not part of the interval. It means you go all the way to 0, but you don't introduce 0. It means all the x is strictly less than 0. And 0 is not part of it. So there will be eventually difference between bracket and parenthesis. But for minus infinity, because minus infinity is not a number, so you cannot include it. It's nothing. It's just an idea. It's a symbol that tells you everything less than 0. Okay. Any other questions before we proceed?
So for like the decreasing, for the quiz, do we have to put all values of x 0 less than or equal to x less than or equal to 2? Or can we just
either?
Okay.
I don't care. All right. As long as you do it correctly.
Thank you.
All right. Usually I have to mute you to stop the background noise, but when you guys want to talk, just unmute yourself, okay? But I have to do that because there is background noise. All right. Any other questions? Very good. All right. So today we're gonna start section. I usually forget the numbers. 1.10. So average rate of change. So section 1.10. So first we'll start with the definition, which is going to be a little bit abstract, and then we're going to work through it during the whole hour. So section 1.10 is the idea of rate of change. Basically, rate of change is the idea how fast something is changing. I mean, how fast. It's like the velocity. When I tell you, okay, your velocity or your speed is like 60 miles per hour, I'm really telling you how fast you are moving. And the rate of change is going to be the notion of how fast my function is changing. Okay. So first I will start with the definition, as I said, and then we work through problem to be able to understand the actual meaning of it, and then how to work with it symbolically. So first the definition, which is, as I said, maybe abstract, but it will become clearer as the lecture progresses. So let f of x be a function. So when I say f of x is a function, immediately you have to see that I have a rule. You give it an input, it is assigned to it an output. So let f of x be a function. So we have input, the input change, the output changes with it. Then the average rate of change, sometimes we, because it's a long sentence, we put the average rate of change, okay, like an acronym, average rate of change of f, of the function f, for the values of x between a and b is defined by. That's what the definition is. Okay. Is the value of the function at b minus the value of the function at a divided by b minus a. So that's the definition that you're going to work with it throughout the whole hour. Right? Okay, so the first example is going to be a graph. I'm going to take a graph just to understand what does this piece means, what does this piece mean in the graph, and how we compute it. So I'm going to just sketch a graph of a function and use it to introduce some notation. So example. So I'm going to sketch a graph, very simple, nothing really hard in my graph. So I do it in front of you. So this is my function. And this is a 1, this is a 2, this is a 3, and this is a 4. And my function, this is a 1 in here. Actually, let me make this is a 2. This is a 4, a 6, and an 8. Okay. And my functions start here. And then let us say it's curving. So that's my function. Up to 3. So I don't need 4 at all, up to 3. Okay, so that's my function. Right? So that's the graph. So before I find the average rate or anything, I'm going to ask you a simple question. What is f of 1 in my problem? Quickly.
2.
2. And what is f of 3 in my problem?
8.
8.
8. Just to make sure we read the graph correctly. Now, the average rate is f of b minus f of a. It means I'm not going to compute. I'm going to just write it. F of b. So, sorry, my apology. So, the average rate of change for x between 2 and 3 is, the definition tells me it's f at 3 minus f at 2. That's the definition. Why I am goofing. My apology again. Between 1 and 3. F of 1 divided by 3 minus 1. Sorry for my... Okay. Now I want to understand what each piece represents. I don't want to compute. Computing is going to be easy. But I want to understand what each piece represents. So first I want to understand the top part. I mean, I want to understand the numerator, at least graphically, what does it mean? All right, let me go back to the picture and stay with me. F of 1, this is f of 1. That's it too. That's f of 1. F of 3 is 8. This is f of 3. So this is your f of 3. So this is my 1 and this is my 3. So when x is going from 1 to 3, the output is changing. It was 2. The output now is 8, correct? So when I am taking the f of 3 minus f of 1, what is really I am doing? I'm doing the following. My function, when x, the input is 1, my function takes the value 2. When my output input is 3, my function takes the value 8. So when I am taking f of 3 minus f of 1, it means I am taking how much my output is changing between 1 and 3. Okay, so that's the 8 minus the 2 is actually telling me how much the function changing. So the distance from to the function was at 2, then the function takes the value 3. So by how much the function changed, that's exactly, this is f of 3 minus f of 1. This is the 8 minus the 2, which is the 6. So what f of 3 minus f of 1 represent is the function, that's its value, all the way here. So this represent, if you want, the change in the y value is how much the y value changed, the change in the y value of f for x between, actually between, I'm going to write this one in word, between 1 and 3. So what this top represent, how much the y value changed. It was 2, it's 8. How much is changed by? It's changed by 6. So that's what the top value represent. And there is a notation for the change. Change is denoted by the following. Delta is usually a symbol for change. Since we are changing the y value, this we write it as delta y. So the top part is how much your function changed when your input goes from 1 to 3. It changes by 6 units. Crucial picture. What's the bottom part represent? The 3 minus 1. The 3 is an input value. The 1 is an input value. So the 3 minus 1 in the picture, watch carefully. I know it's 2. I'm not really talking about that. The 3 minus 1 in the picture represent this. This is your 3 from here to here. And this is the 1 from here to here. So the 3 minus 1 basically is telling you that when x is between 1 and 3, changes from 1 to 3, by how much it changes? That's the 3 minus 1. Means how much your input changed from 1 to 3. That's the 3 minus 1 in the problem. And we call this the delta x. It means the change in the x value. So this is going to be the delta y, by how much your output changed, and this is the input change. So the 3 minus 1 is the change in the x value, the x between x equal to 1 and x equal to 3. So it's the change in input between 1 and 3. What's the change in x? X changed by 2 units going from 1 to 3. And we denote it by delta x. Delta is a symbol, it's a Greek letter that represents a change. That's what that, it actually refers to difference because we're taking the diff. So delta really is the D in Greek because delta represents the difference between two things. And the change we're actually taking the difference between the two outputs. All right. Now, with this being said, the average rate of change of this function f, we start writing it like that. So the average rate of change for x between 1 and 3. So sometimes we write it as the following. So it's f of 3. I'm skipping this line on purpose. It's exactly f of 3, the value here, minus f of 1 over 3 minus 1. So we write this as delta y because the numerator is always how much my output change over the delta x, because that's how much the x change. So this is equal. Now we compute that, the computation, we have it. F of 3 is 8. F of 1 is 2. 3 minus 1 is 2. That's 6 over 2, which is equal to 3 in my particular scenario. Okay, so the most important idea here is to understand the numerator. So that the numerator and the denominator. What the numerator tells me is between 1 and 3, the output changed. It was 2, now it's 8. So the difference represent, this is the pictures that I want you to get it, is from f of 3 all the way down to here. That's really what the output is, how much, that's the numerator. That's how much the output changed. And 3 minus 1, it means from 1 to 3. X changed by how many units? By 3 units. Okay. So,
I'm sorry, what does the delta stuff mean? My Zoom crashed whenever you explain that.
okay, delta is the letter D in Greek. All right? Where is the D coming from? The D is difference. All right? D is coming from the difference. Here, I'm taking the difference between two quantities. The value at 3 minus the value at 1.
So just another way to write the equation is delta y and delta x, because it's the difference in y and difference in x.
Mm-hmm.
Okay.
Yeah, but what it is, you have to know what it is. It means f of 3 minus f of 1. I mean,
Yeah.
okay. All right. So let us rewrite the average rate using this new notation. And then we take examples to see, in a word problem, what does this mean? And then we work with it symbolically. All right.
I have one question.
Yes.
So, for the average rate of change formula, is there any real difference between that and the slope formula? Because slope formula is
it's actually a slope. It is a slope. It is a slope. But the slope of what? I'm going to tell you the slope of what? If I take this line, not the curve, this line. So if I call this point A, which is 1, it is a slope. And B, which is 3, f of 3. You saw this dashed line I'm writing? Do you see the dashed line?
Yeah.
Okay, so, but I don't think you see those points here. I'm going to rewrite them. When you don't see something, let me know. So this point is 3 for the input, and this is f of 3. And this is 1 f of 1. So the average rate is the slope of the dashed line, because the slope of the dashed line is f of 3 minus f of 1, change in output. That's what you compute the slope, divided by 3 minus 1. Okay, and that's very actually important in the graphical interpretation. So it's a slope, but the slope of which line? Because this function is curving. I cannot say the slope of the curve. It's the slope of the line which is joining those 2 points. And in math, in calculus, this line will be given a name and it will be called a secant line. So it has a very specific name. It's called a secant line. And believe me, calculus start with that. That's the heart of studying calculus, studying the notion of rate of change. So let's write this down on the picture here because you guys brought it up. So the average rate of change is the slope of the line AB, or the dashed line in my picture. That's the average rate of change. You're absolutely correct. It's the slope of this dashed line. Please ask more questions. Okay. So very good. So now the average rate, I will rewrite it using delta y, delta x, and then I'm going to repeat the same thing actually. So average rate of change of a function f for x between a and b is the change of y, the output values, over the change of x. But we have to understand what it is. It means the value of the function at the right minus the value of the function here, how much my output changed, divided by b minus a. And graphically, it's the slope of the line, because you brought it up, I will definitely, of the line that join the point a f of a and b f of b. Okay. Right. So now we're going to take a word problem, a simple word problem, and actually compute the average rate and try really to make sense out of it. What does it really represent in word problems and why it's a very important idea? Questions? Very good. All right. So example number 2. All right. Suppose I have a function f of t, and this function tells me the population in a certain town. So it's a population in a town. Just you make up the name of the town. I don't really care. At time t, where t equal to 0 correspond to the year 2000. So t equal to 0, okay, 2000. The graph of f of t is given. So I'm going to work with graph. Is given. Okay. So now we're trying to do a word problem to understand what it means. So this is my graph. So my function is the population. So in this case, f of t, t is the input. So t is going to be time. So this is time in years. That's my input. My output is the population. This is f of t is the population. So on the vertical axis, I'm going to put the population. Okay. And assume that it's a, human population. So it's people. And this is my graph. So I'm going to, this is 10,000. When I put those 2 dash, it means this should be bigger than it is. But to make the picture easier, I have to do that. So 10,000 at t equal to 0. And then, for example, let me see here, 10,500. So I'm putting the numbers so you can see exactly. And this is right here. So after 5 years, that's the number I want. And then, so somewhere here, let us say this is 10,860. And after 8 years. So this is 8. And I'm going to draw that. I'm going to connect. Okay, so that's the graph of my population. Okay, so on the side, let me pick up the value. So I make sure we all are on the same. So this is time in years, and this is f of t. And f of t represent population. Right. So t equal to 0 correspond to the year 2000. So at t equal to 0, what's the population quickly?
10,000.
10,000. At t equal to 5, because that's the only numbers I gave you, 10,500. Okay, I'm putting the value here so we all know what we're doing. At t equal to 8, the population is, according to my picture, 10,860. Okay, so that's my graph. Now my question is, find the average rate of change. Find the average rate of change of f, of the population. Since I know what f represents, so I feel comfortable telling you of the population. That's another way of telling you of the function f for t between 0 and 5. Okay, and my goal today is not only in this problem to find the average, it's also we want to find what does it mean. So we're going to give it a unit and interpret it. So, and interpret. What does this mean? All right. So let us compute the average rate. On the picture, what's happening? So what's the average rate of change? Between 0 and 5. What's the average? Is the population at 0 is 10,000, and the population at 5 is 10,500. So I do it on the picture so you understand it. So what is the average rate? It's how much the population changed from here to here. That's going to be the change in population. Change in population from here to here. We're going to divide it by how much the time it changed. That's what's going to be. So I'll write it and the picture everything. So the average change is how much. I'm using P instead of Y because my vertical axis really represents the population. So it makes more sense to use the population value than Y values, which doesn't represent what the problem is about. So over T. So this is equal to what? What's the change in population? It's how much we had 5 minus the population at 0 divided by 5 minus 0. It's equal to what? What's f of 5 minus f of 0? It means the population after 5 years minus the population at t equal to 0 divided by 5. Please stop me if there is anything you don't understand. So it's going to be equal to what? That's 5. That's 5. Okay, on the picture, what we are doing. Now I know it's 100, but let me stop for a second to understand every aspect of it. So let me go back. On the picture, as the population, as time goes between 0 and 5, it means the year 2000 and 2005, what's happening? When the year here, as time go by, the population changed. It was 10,000. So the change here, that's the change in population. That's how much the population changed. The population changed by 500. So we were at 10,000. We grew up to 10,500. So this is by how much the population changed. That's the 10,500 minus the 10,000. That's the 500. That's the f of b minus f of a. It's telling me how much the population changed. When I divide by 5, it means this is the 5. It means between 0 and year 2000, 2005, by how much the population changed. It changed by how much time changed? By 5 years. And the average rate is the change of the population divided by the change in time. But now, so let us give it a little bit of meaning. The 500 tells me that in 5 years, so this is people here, means the population changed by 500 people over a period of 5 years. So when I divide them, I'm going to get 100. But what does this 100 tells me? What does this 100 tells me?
That every year there's a population change over 100.
Right. It means, so what's the unit I'm going to give the average rate? It's going to have a unit. It's telling me that when I have 500 over 5 years, and I divide 500 by 5, as your classmate said, it means the population is changing by 100%, but 100% is not correct per year. So the unit is going to be the unit of your output, which is the people, divided by the unit of input, which is years. So it means the average rate is 100% per year. What does this mean to us? It means on average, the population, on average, the population changed by 100% per year between t equal to 0 and t equal to 5. Okay, so it's really a matter of asking ourselves how fast was the population changing between 2000 and 2005. The population was changing at the rate of 100 person per year. That's right. So it's how fast the population changing. That's what the average rate of change, the speed of the population. Now, does it mean it's changing exactly 100 per year? Yes or no?
No, we can't know that.
No, it's an average. It's like your speed. When you guys tell me, okay, we are average 60 miles per hour, doesn't mean you are driving exactly 60 miles per hour. That's really the idea of average rate. You can be driving 90 because the police was not watching you. And then the minute the police is somewhere in there, you start driving 40. But your average is 60 miles. That's exactly the average rate. It's the speed at which the population was changing per year. So 100 per year. Okay, that's really the idea of average. It's the speed that your function is changing. Okay. I can ask you the same question between 5 and 8. So let me pick up another paper and let's do very quickly between 5 and 8. So I'm interested, how fast was the population changing between 5 and 8? So question number B, find the average rate of change for t between t between 5 and 8 and interpret it. So now I'm interested, is this the same problem between 5 and 8? So what's the average rate of change? Is how much the population changed between those two times interval divided by, how long it took to do this change. So graphically now, I am here. This is my 5 and this is my 8. So my population was at 10,500. So then it's changed. So now here, the change in this case between 5 and 8 is 10,860 minus 10,500. So the change is the value at 8 minus the value at 5 divided by the time it took. But between 5 and 8, the time it took is 3. So divided by 8 minus 5. So this is going to be equal to, okay, 10,860 minus 10,500 divided by 3. I try to pick easy numbers. 860 minus 500, this is going to give me 360 divided by 3. It means 120. Now, what's the unit of 120? Please, every one of you try to answer the questions. 120. If I ask you what's the unit, what is the unit? Person per year. Okay. It means between the time 5 and 8, the population at 5, it means 2005 was that much, it grew to 10,800. So the population has changed. So between here and here, the population changed by 360 over a period of 3 years. The average rate is how much the population changed divided by 3, which is going to give you 120 person per year. It means on average, it was changing that much. Now, why those two numbers are good? So now the question would be, when was the population growing fastest? Between 0 and 5 or between 5 and 8? When was it growing fastest? So if you tell me, if I look at the average rate, you tell me, between 0 and 5, it was growing by 100 per year. Between 5 and 8, it was growing by 120 per year. So the growth was faster between 5 and 8 than between 0 and 5. So it really helped me to understand how fast the function is changing. Okay. Any questions before I move on? Please ask your questions. All right. Okay. I take another example, again, a very simple example, and then I will do a more, symbolic problem, which are crucial. So now suppose my example number 2 is along the same line. Okay. So here, my function represents the temperature. So my output is the temperature in Fahrenheit, degree Fahrenheit, in Chicago, let us say, on January 1, 2021. So throughout the day, the temperature changes. And suppose I give you a bunch of numbers. So that's time. And the temperature, this is f of t. Okay, that's the temperature. And I tell you at t equal to 0, it means at 12 a.m. in the morning, the temperature was -3. So t in hours. Okay, and let me say 6, 10, and 12 noon, the temperature crept up a little bit. 18, it went down to 7, and in the evening it went back down to -3. All right, so that's the temperature. Suppose I ask you the following question. Find the average rate of change of the temperature of the function f for t between the time 12 noon and 18. It means 6 o'clock in the evening. Okay. So who can tell me what was the average rate? Who can do the math in a minute? And unit with it. Okay. You guys got the answer? So maybe pick one of you. How much did you guys get? Anybody got the answer? Let's do it together. Between 18 and 12. So between here and here, what's the average rate? So it's the temperature at 18 minus the temperature at 12 noon. That's the change temperature divided by the time, 18 minus 12. Okay. At 6 o'clock, the temperature was 7. At noon, the temperature was 13. And the time passed is 6. So this is going to give me -6 divided by 6, which is -1. That's using the formula verbatim. And now let us understand the picture here. It means between 12 and 18, the temperature, so I'll use delta T, stands for the change in temperature, is how much? Temperature was 13, it went down to 6. So by how much the temperature change? It's always the value at the right time at 18 minus 12. So it's 7 minus 13, which is -6. The minus is important because the minus tells me that what's going on between 12 and 18. The minus tells me what? That the temperature decreased by -6. So the minus is an important part. It was 13. It went down by 6. It means the temperature, the change is -6. That reflects the idea that the temperature was 13, but then the temperature went down all the way to 7. So the minus reflects the idea that the function decreased between 12 and 18. So it's an important part of the problem. So -6 here, it means the temperature went down by 6 degrees. But how long it took to do that? It took 6 hours to do that. So when I divide, it means the temperature was average going down by -1 degrees per hour. That's the average between 12 and 18. So if a function, the value of a function decreases from A to B, like from 12 to 18, this is reflected by a negative average rate. So the negative here, this minus, tell us, the minus tell us that the temperature decreased on average of 1 degrees per hour. So having negative is a part of the problem. It tells me that things are going down instead of going up. So the average rate could be positive, like in the population problem, because the population increased. And here, because the temperature decreased, therefore we have a negative change. The temperature went down by -6 over a 6 period. So we reflect this immediately in the rate by having a minus. So what the average rate tells us is, on average, how fast is your function changing? You guys are very quiet. All right. So in word problem, when you have a table, we can do the average rate the way we're doing it. Now, if the function, just we do it symbolically. Now, suppose I tell you f of x equal, so how do we work with average rate symbolically? Suppose I tell you f of x equal x squared plus 4. So there is no story at all in here. And I ask to find the average rate of change for x between 1 and 5. So very symbolic approach to that. So here I just use the formula. So the average rate of change is going to be the value at 5 minus the output at 1 divided by 5 minus 1. Okay, so in a symbolic way, we just use the formula verbatim. So on the side, what is f of 5? So let me compute f of 5, and let me compute f of 1 on the side. What is f of 5? F of 5 is 5 squared plus 4, which is 24. I meant 29. What is f of 1?
5.
It's equal to 5. Okay, I do them on the side. So f of 5 is, if you want, I rewrite what I wrote. So it's 5 squared plus 4. So it's just applying the formula, nothing really deeper than that. Minus 1 squared plus 4. So that's the value at 5. And that's the value at 1. So it's going to be equal to, that's the 29 minus the 5 over 4, which is 24 over 4, which is equal to 6. So if your function given by a formula, finding the average rate is basically apply the formula verbatim. Okay. Now, suppose I make the problem a little bit harder, and I tell you find the average rate for X between, you're gonna hate me for it, if you don't already, 2 and 2 plus H. So this problem is mainly to improve our concept of working with function when the function is given by a formula. So how do I find that? So it looks fairly complicated, but it's really not. So the average rate of change in this scenario, I'm going to use the formula here. F of 2 plus H, the value here, minus the value here, divided by B minus A. Okay, so this problem is purely symbolic. All right, what's F of 2 plus H? I'll do them on the side. Okay. My function f of x is x squared plus 4. So f of 2 plus h is 2 plus h squared plus 4. Okay, I'm computing that term. So let's is equal to what? Now we've done this several times. Plus 4. So now I distribute 4 plus 2h plus 2h plus h squared plus 4. And this would give me h squared, this term, plus 2 plus 2 for h plus 8. Okay, that's f of 2 plus h. F of 2, so I'm doing them on the side to make sure we know how to do them. F of 2 is 2 squared plus 4, which is give me 8. So this is pure symbolic approach. So it's going to give me minus f of 2 plus h is h squared plus 4h plus 8. F of 2 is 8. The denominator, 2 plus h minus 2. 2 minus 2. Give me an h. And finally, okay, I will get h squared plus 4h plus 8 minus 8 divided by h. Right? So those will go away. And I will be left with h squared plus 4h divided by h. So the reason we practice those problems, which is you tell me, why is she doing this? Is it calculus start basically with a lot of quantity like this. So if you ever of you guys want to do calculus, which is probably, I hope some of you will do that, you will have to deal with this expression continuously. So the idea is that let's get the practice to do those kind of expression. That's the main reason we do those kind of abstract ideas, because you have to be trained to do them in a calculus course. Okay. All right. So let us sum up. The average rate of change is basically represent in words how fast your function is changing. That's really the main idea. So the formula is simple, but the meaning is really what we care about. It's how the speed. So in the population, when I find the average rate, how fast was the population changing per year? That's really what the average rate gives me. In the temperature, how fast was the temperature changing per hour? That's what the average rate really tells me. It's like the velocity, the speed, sorry, how fast things are changing. So that's in a word problem. Symbolically, you just can work with it by just plugging the function. All right, I have to stop right there. Your quiz is like usual, is on Brightspace. And I'll share it with you. So you guys go to Brightspace as usual, go to quiz. Most of you have to have it. Okay, so you go to content up here. Sorry, my computer is slow. I hope yours is not. Okay, and then you click, you go down, quizzes and exams. You go to quiz 2. Then you click here and the quiz is in front of you. All right. Now for the first questions, I want you to read it carefully. What's your input? What's your output? Is the function increasing, decreasing? And then graph it. Don't make a big deal. Graph it. The function is, you're going to graph it like this. Just graph it. You don't have any value, but what do you think? Does it increase or decrease? So that's really what I want from the graph. But the most important thing I want is the labeling. What goes on the horizontal? What goes on the vertical? I care about the labeling. So I want you to read it very carefully. What's your input? What's your output? And if you're going to graph it, what should go on the vertical? What should go on the horizontal? But the graph is either increasing or decreasing. One of them. Think about it for a minute. Okay, good luck, guys. Sorry, the quiz has 2 pages. The second page is fairly simple, but just don't miss it. Please put your camera on.